Hi everybody. In our previous class, we discussed about addition and subtraction of collinear vectors, and we learned triangle of vector addition also. Yes, very good. Right, let us continue the topic. What is our topic? Vectors. Very good. I would like to ask a question. Let us see how many of you will tell the correct answer. Tell me, 3 plus 4 is equal to how much? What is your answer? Yeah, it is 7. But I am going to prove today 3 plus 4 is equal to 5. Challenge? Yeah, come on. Very good. Consider two orthogonal vectors. Two orthogonal vectors. You know what is meant by orthogonal vectors. If the vectors makes an angle 90 degrees, then we call them as orthogonal vectors. Okay, let us take this is vector A, whose magnitude is 3 meters, and let us take this is vector B, and its magnitude I am taking as 4 meters. I think you might have understood. Yeah, right. What I am going to do is I am going to add these two vectors, means I am going to do A plus B, then I will get a vector C. Understood? I am going to add these two vectors, means 3 plus 4 I am going to do. Let us see how to add the two vectors. We know that the tail of the second vector should be joined to the head of the first vector, so that B will be shifted to here. Vector B will be shifted to here, and the vector C is the resultant vector, is drawn from the tail of the first vector to head of the second vector. This is our vector C. Right, now you observe carefully, it looks like a right angle triangle. Yes or no? This is a right angle. So that in right angle triangle, we know how to calculate the length of a hypotenuse. Right, then length of the hypotenuse is C. Let us see, the magnitude of vector C is equal to, how do you get? Root over 3 square plus 4 square. How much is this? Root over 9 plus 16, that is 5 meters. So here 3 plus 4 is equal to how much? 5. Did I prove or not? Yes. Understood? Here you see the difference between vector addition and scalar addition. This is simply called as a scalar addition. This can be called as scalar addition. Okay, what is this? This is vector addition. Understood? So scalars can be added or subtracted by using simple rules, but vectors are added or subtracted by the geometrical rules only. Understood? Right, here let us see, if A and B are in the same direction, A and B are in same direction. Okay, then what is the sum of these two vectors? This is A and this is B. Then what is the sum of these two vectors you are going to get? That is simply A plus B, that is 7. Right? So if they are in opposite direction, then what? So this is A and this is B. This is our resultant vector. How much is this? The magnitude of A plus B you will be getting as 1. Yes or no? Right? So from this you can understand one thing. A plus B have the value 5, 7, 1. That means it can be any value? No. It can be values from A plus B to A minus B. Right? It is the maximum value of sum of the two vectors. This is the minimum value of sum of the two vectors. Maximum value and minimum value. Right, Nana? So it can have any value between these two. See, the maximum value of that is 7. Minimum value is 1. It can be any value. See 5 here. right, Nana? So the sum of the two vectors can be any value between a plus b to a minus b. Understood? Right. See, for example, two forces let me take, that is F1 is 6 Newton and F2 is 10 Newton. Okay, what is the maximum value of F1 plus F2? Maximum value, yeah, it can be 60 Newton. What is the minimum value of F1 plus F2? Yes, it can be 4 Newton. In between, its value can be anything. Understood? In between 4 to 16, its value can be anything. That is F1 plus F2 value can be anything in between these two values. It can be 5, 6.5, 7, 8, 9, whatever it may be, 9.5, 10.5 like this. Okay, this is the beauty of vectors addition, right? So by this you understood one point. What is that? So the vectors cannot be added. Vectors cannot be added by simple algebraic rules. By simple algebraic rules. By using simple algebraic rules, we cannot add vectors. Yes or no? Simple algebraic rules, 3 plus 4 is 7 only. Right? So that is. Now let us see here. Take two vectors. A is 3 meters east. Let there is a vector A that is 3 meters in magnitude and direction is east, and another vector B is 4 meters and its direction is 60 degrees east of north. Right? Now let me draw the vectors. First I am drawing vector A. This is towards east, and B, vector B is 60 degrees east of north. That means the vector is moved 60 degrees from north towards east, right? So suppose this is the vector B, it is rotated through an angle 60 degrees, right? Towards what? Towards east. Understood? This is our vector B. I am going to add these two vectors. So let us see how. This is vector A, right? So how to add B? Tail of the B should be placed at the head of the vector A. So this is. Now what will be the resultant vector? This is the resultant vector C bar. So C bar is equal to A bar plus B bar. Now how I can calculate the magnitude of vector C? Means length of vector C. How can I calculate? Can I take again root over 3 square plus 4 square like that? It's not possible because it is not a right angle triangle. Am I correct or not? So then these kind of problems can be solved by learning parallelogram law. What is that, sir? Parallelogram law of vector addition. Right. So this is an important one, because in all physics chapters, when we are dealing with the vector physical quantities, we use this mainly. So that listen carefully and try to learn it. It's very easy, right? So you know very well about a parallelogram, right? Let me draw a parallelogram. This is a parallelogram. Am I correct or not? So this is A, B, C, D is a parallelogram. So the opposite sides are equal in the parallelogram. Yes or no? Very good. And this is known as the diagonal of the parallelogram. Yes? This is the mathematical knowledge about parallelogram which one can have. Now what is parallelogram law of vectors? Let us see its statement first. If two vectors acting simultaneously at a point, that means, see this is the point. From this point, two vectors are acting on a body simultaneously, means without no time gap. Okay, now if two vectors acting simultaneously at a point can be represented both in magnitude and direction by the adjacent sides of a parallelogram. Which are the adjacent sides of a parallelogram? this one and this one. Okay, that means if the vectors are represented in this way, acting from the same point, common point, this is called common point, and represented the sides of a parallelogram both in magnitude and directions. This is direction, this is direction. Magnitude means length of the vectors. Then what will be its resultant vector? Then the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram passing through the same point. This is the point. This is the resultant vector. Okay, both in magnitude and direction, it is the diagonal of the parallelogram. Am I correct or not? So this is the simple statement, right? Once again, if two vectors represents the sides of a parallelogram both in magnitude and direction, then the resultant vector is the diagonal of the parallelogram passing through the same point, right? Let us take this is vector p bar and let is vector q bar, and the angle between the two vectors is I am taking as theta. Okay now, so as these are co-initial vectors, this angle is theta. Okay, Nana? Now I want to add two vectors p and q. If I add p and q, I will be getting a resultant vector. I have taken this as r. Now I want to calculate magnitude of vector r. Magnitude of vector r, it can be represented by modulus of r. So it can be written as root over magnitude of p whole square plus magnitude of q whole square plus 2 magnitude of p into magnitude of q into cos theta. I am writing here, see that, root over p square plus q square plus 2pq into cos theta. It looks like a plus b whole square. A plus b whole square is what? A square plus b square plus 2ab. But here 2ab cos theta. What is this theta here? Theta is the angle between the vectors. You remember this one. Theta is the angle between the vectors. Okay, by using this formula one can calculate the magnitude of the resultant vector, means length of the resultant vector can be calculated by using this formula. Understood, Nana? Right, this is the magnitude of the vector r. Then how to calculate its direction, sir? Because it is a vector physical quantity. When you add two vectors, you will get another vector. So we got magnitude. Then what about its direction? It has direction or not? Very good. So let us take the resultant vector makes an angle alpha with the vector p. Okay, the resultant vector makes an angle alpha with vector p. Here alpha is the direction of r. Alpha is the direction of r. So from this we can write tan alpha is equal to q sin theta by p plus q cos theta, right? This is the direction of r. Or else you can write this as alpha is equal to tan inverse of q sin theta by p plus q cos theta, right, Nana? So q sin theta means magnitude of q into sin theta by divided by p, magnitude of p plus magnitude of q into cos theta is the direction of resultant vector r that made with vector p. If I want to calculate angle made by the vector q, then this is that. Let us take this as beta. Then it can be calculated by using tan beta is equal to, you tell me here, if tan alpha is q sin theta. Okay, when the vector makes an angle p, we have taken q sin theta by p plus q cos theta. Now vector made by the angle with q, then it is p sin theta by q plus p cos theta. This is the angle made by the vector with q. Or else you can do simply one thing. This total is theta and this is alpha. Then beta can be written as theta minus alpha. Simple. Got it? Very good. So in this way, by using the resultant vector's magnitude and direction, we can calculate the resultant vector's magnitude and direction. Right, Nana? Let us see one example. Let us see an example. So we learnt magnitude of the resultant vector is how much? Root over p square plus q square plus 2pq cos theta. And what is the angle made by the vector? With the vector p, that is alpha is equal to tan inverse of q sin theta by p plus q cos theta. Yes or no? Right. Now let us take, there is an object. On the object, two forces are acting simultaneously at an angle of 60 degrees. Okay. Let us take this vector is force F1 is 4 Newton. This vector is F2, that is magnitude is 5 Newton I have taken. These two are acting on the body simultaneously from a point. Okay, now I want to calculate resultant force. Resultant force F. This is nothing but what? F is equal to F1 plus F2. Okay, then what is the magnitude of F now? Root over F1 square plus F2 square plus 2 F1 F2 cos theta. Yes or no? So F1 square is 4 square plus F2 square 5 square plus 2 into F1 F2. So 4 into 5 into cos theta, cos 60 degrees. Yeah, that is equal to how much? Root over 16 plus 25 plus 40 into cos 60 value 1 by 2. Right. So then that is root over 61 newtons is the magnitude of the force. Understood? So if you take this as the resultant vector F, then its magnitude is root 61. Means nearly how much? Nearly 8. Yeah, approximately less than 8 Newton. So that is the thing. Understood? Right. Now I want to calculate direction. Direction of F. How? That is the formula alpha is equal to tan inverse of F. Now tell me that this is q sin theta. Q means second vector. This vector, that is F2 sin theta by F1 plus F2 cos theta. This is the angle made by the resultant vector with F1. Yes or no? Right. That is tan inverse of F2 sin theta. F2 is how much? 5 or 4? 5 into sin 60 root 3 by 2 by F1 4 plus F2 5 into cos 30 1 by 2. Right. If you simplify, you will get 5 root 3 by 13. This is the angle made by the vector with F1. This is the direction. Okay, here alpha gives the direction. Angle is nothing but the direction. Understood? So in this way, one can calculate or one can solve the problems. Right, Nana? Let us see another example. Here, find a plus b and a minus b if a is equal to 4 units and b is equal to 3 units, and the angle between them is 60 degrees. Okay, now let us see a plus b is equal to, so magnitude of a plus b let us take as c. Right, that is equal to, what is the formula? Root over a square plus b square plus 2ab cos theta. So a square, that is 16 plus b square 9 plus 2ab cos 60 degrees. Okay, so that is square root of 25 plus 24 into cos 60 is 1 by 2. Right, that is root over 25 plus 12, right? That is root over 37 units. This is a plus b vector's magnitude, right? How will be the a plus b vector magnitude? Resultant of a plus b will be how? This is a and this is b. Resultant is this. Am I correct? Yeah. So or else you can draw vector b here, so that this will be the c value, right? This is c is equal to a plus b, right? Now we are going to calculate a minus b vector's magnitude of a minus b. That is root over a square plus b square minus 2ab cos theta. Okay, like a minus b whole square, right? So this is root over a square, again 16 plus 9 minus 2 into 4 into 3 into cos 60 degrees, right? That is root over 25 minus 24 into 1 by 2. That is root over 25 minus 12. That is root 13 units is the a minus b vector's magnitude. How will be the a minus b vector magnitude? See, this is vector a and this is b. Minus b means this is minus b. Yes. Now this is our vector c. This is equal to a minus b vector, that is c. Understood? This is a minus b vector. This is a plus b vector. See, the directions are different and their magnitudes also different. Here it is magnitude root 37 and here its magnitude is root 13 units. Understood, Nana? So this is a plus b vector and this is a minus b vector. So by using this you can calculate. You can calculate direction also. Okay, now so we know formula. So here direction, there direction also you can calculate, right? So see the question. The sum of magnitudes of two forces acting at a point is 16 Newton. So magnitudes sum, that means a plus b is 16. Here a and b are the magnitudes of the vectors, it is 16. If the resultant is normal to the smaller force, resultant, let us take r, that is normal to the smaller force. Let us take here a is a smaller force. So let me draw, this is a. This is the smaller force I have taken. Resultant vector r is normal to the smaller force, right, Nana? And has a magnitude 8 Newton. The resultant vector magnitude means vector a bar plus vector b bar magnitude. Okay, that is r magnitude is 8 Newton. See here, these are the magnitudes of the vectors. This is the magnitude of resultant vector, right? Then what we need to calculate? Then the forces are what? Means a and b we need to calculate, and angle between a and b also we need to calculate, right? This is a and r. How will be vector b here? No, this way it should be, because resultant vector is always lies between two vectors. Understood? So resultant vector is always drawn in the middle, right, Nana? Now see here, I want to calculate this one. Now what is the formula? Magnitude of resultant vector is equal to root over a square plus b square plus 2ab cos theta. Yes, so that is root over a square. Let us take a square plus b square, that also we don't know, plus 2ab cos theta. 2ab cos theta. So that this can be written as r square is equal to a square plus b square plus 2ab cos theta. Can I write? Yeah. From this, r square is how much? 8 square, that is 64 is equal to a square plus b square plus 2ab cos theta. Yes, Nana? Now let us see that. Here, the angle made by the resultant vector with a is 90 degrees is given. This is what alpha. Alpha is equal to 90 degrees. So we have a formula. What is that? Tan alpha is equal to b sin theta by a plus b cos theta. Remember, this is the angle made by the vector with the a, right? That is tan alpha, tan 90 degrees. Tan 90 degrees is equal to b sin theta by a plus b cos theta. Here tan 90 value infinity. Tan 90 value is infinity. So infinity means what? Something by 0 is infinite. Understood? Therefore, this is something by 0. If this value is 0, then tan 90 value will be infinite. That means what? A plus b cos theta value should be 0. Understood? So tan 90 is equal to b sin theta by a plus b cos theta. If this value is 0, then only tan 90 is infinity. So that from this what can I write? B cos theta is equal to minus a I can write. Okay, substitute this value in this one. That is what? 64 is equal to a square plus b square plus 2a into b cos theta value how much? Minus a. Okay, this can be written as a square plus b square minus 2a square is 64. That is b square minus a square you will get as 64. It can be written as b minus a into b plus a. Can I write? Yes. Right, Nana? Now already we have a plus b value. How much that is? 16. Already we have seen that a plus b value is 16. So now substitute that value. That is 64 is equal to b minus a into 16. From this, b minus a is equal to how much? 4. Yes or no? Now we have b minus a, and what is b plus a? 16. Now solve it. 2b is equal to, what is that? 20. So that b is equal to 10 Newton. B is equal to 10 Newton. Then a is equal to how much, sir? 6 Newton. Yes or no? From this, if you substitute that, you will be getting 6 Newton. Those smaller forces, right? Now we got the forces. Next, what we need to calculate? Angle between two vectors, means theta value we need to calculate, right? So from this we got one thing, what? B cos theta is equal to minus a. You substitute the values here. 10 into cos theta is equal to minus 6. Yes, then cos theta is equal to minus 6 by 10. Minus 6 by 10. So you can simplify that, or else you can leave it as that. So then theta is equal to cos inverse of minus 6 by 10 is the answer. Understood? Right. See this question. If two numerically equal forces P and P acting at a point produces a resultant force of magnitude P itself. Okay, now? So now, what is the angle between the two vectors? Let us take first vector as A, and whose magnitude is equal to P, and B, that's magnitude also P, and the resultant vector magnitude also P. Magnitude of A, magnitude of B, and magnitude of R or P. Now I want to calculate the angle between them, means theta is equal to how much? Then what is the formula for resultant vector? That is R is equal to root over P square, means A square plus B square plus 2AB cos theta. That is equal to root over A square is P square plus P square plus 2P into P square cos theta. Yes or no? So this is again P. That means I can write as P square is equal to P square plus 2P square cos theta. Can I write or not? Yeah, very easy. So that is P square is equal to 2P square plus 2P square cos theta. So then from this 2P square cos theta is equal to minus P square. Yes or no? Yeah, simple mathematics. Then cos theta is equal to what? Minus half. Then you will be getting theta value as 120 degrees, because cos 120 is minus half. Therefore, the angle between the two vectors is 120 degrees. Understood? So in this way one can solve problems based on parallelogram law of vector addition. This is very useful in all the chapters of physics. Once again, I'm telling you, practice. Okay, so thank you very much. This is today's class. We'll meet in the next session.